There are several ways to solve quadratic functions. We've gone over graphing, factoring, completing the square, and today we're going to use the quadratic formula, which should be pretty familiar to you. The quadratic formula looks like this, and if you want to see the proof, which is done by completing the square, it's on page 356 of your textbook. I just want to circle this right here and see if you think that looks familiar. That is the axis of symmetry for your parabolas. Okay, before using the quadratic formula, your quadratic equation must be in standard form, which means it needs to look like ax squared plus bx plus c equals 0. And we want to do a couple of examples using the quadratic formula to find zeros. So our first problem is g of x equals 2x squared minus 16x. Now the reason why I circled the minus 16x is because when you pick out a, b, and c, you always need to take the sign with the number. So when we're looking here, we have a is 2, b is negative 16, c is 27. All right, we'll start this problem out. And we want to do, and be careful when b is negative, because sometimes people will see that this is a negative and they forget that this is already a negative here. So one way you can think of it is take the opposite of b. I'm just writing negative here, and then I write in what b is, and then it's b squared, so put that in parentheses and be careful how you enter that into your calculator. Do not do negative 16 squared like that. Because that will give you a negative number, and we know that when we square a negative number, it turns out to be a positive number. So be real careful how you're entering that into your calculator. Your calculator will compute it exactly how you put it in. And then it's minus 4 times a times c. And all of that goes over 2 times a, which is 2. All right, then we're going to simplify here. And remember, you're subtracting in between the b squared and the 4ac. So we're subtracting here. And one thing I want to say too, sometimes it helps students to write the subtraction sign and then just multiply all of these together, because sometimes this might be negative or these two may both be negative. So if you just write the negative down and multiply all, or the subtraction sign here, and multiply all three of those together, sometimes that helps with mistakes when you're entering those in your calculator. And then 2 times 2 is 4. All right, so then you just need to simplify, and we end up with 40 underneath the square root sign. And remember, you're going to do plus or minus here, and that goes over 4. Now 40 has a perfect square in it, so you always have to simplify. So over to the side here, I did a factor tree. Let me just slide that over so you can see. Factor tree, and it simplified to 2 times 2 times 2 times 5. So I circled the pair here. They have to come out as a pair because it's a square root. So that comes out as a 2. And we can simplify 40 as 2 times the square root of 10, because the 2 comes out here. Whoops, can't see that there. There we go. The 2 comes out, and what we have left underneath there is 10. So it's going to be 2 times the square root of 10, or 16 plus or minus 2 times the square root of 10 over 4. Okay, now, when you do this, you need to reduce your fraction, and sometimes it helps to split these up, because sometimes students get confused about how you reduce when you have two numbers with an addition sign in between. You actually have to reduce all 3 numbers here. But if you split it up and you just put 16 over 4 and then you put this over 4, sometimes less mistakes are made because you can see easier that you need to reduce both of them. So when I do reduce both of them, I end up with a 4 plus or minus 2 times the square root of 10 over 4. And then you're finished with that one. All right, let's look at the next one. The next example we have is 3x squared minus x plus 8. And identifying a, b, and c, we can then substitute those values into the quadratic formula. And again, this b is negative, so it's going to be negative and then a negative 1. Plus or minus, and then we just substitute the values for b, and then 4 times ac, and that goes over 2 times a, which is 3. And then you just simplify. Now what happens here is when we subtract, we're going to end up with a negative underneath the radical sign, which is fine. So what we're going to do is just simplify that, make it the square root of negative 95. And the other day we learned how to simplify square root signs that have negative numbers underneath them. We're going to split that up into negative 1 plus the square root of 95 times negative 1. Because when we multiply those two together, we'll get that negative 95 back, and that's over 6. And I have to check and see if I can simplify this at all. I take 95, I do, oops, let me slide that over. 95, I do a factor tree, and I have two prime numbers, and neither of them are repeated. So that's as far as I can go with 95. But I need to change the square root of negative 1 to I. Now, usually when you are writing this, you need to make sure that the I goes in front of the square root sign. So I have negative 1 plus or minus I square root of 95 over 6. And if you split those up, you can't reduce any further, so we're just going to leave it like that. All right, now, last thing we need to talk about is when you're finding the zeros of a quadratic function, one of three things can happen. You can see that your graph will cross the x-axis in two places. That's the most it can cross. It could cross in one place, or it may not cross at all. And when that happens, you have a complex root. So we're going to talk about the discriminant, and the discriminant is represented by b squared minus 4ac. Now that's part of the quadratic formula, and basically what you use it for is to tell what type of solutions you have. So since you're doing b squared minus 4ac anyway, you can look at it, and before you're finished with your problem, you can tell if your graph is going to cross the axis in two places, one place, or no places in the real number system. So let's take a little closer look at the discriminant to see if we can, instead of trying to memorize it, have it make sense. You're always going to have two solutions unless your answer is 0. So this is the only time there is one solution. All the rest will be 2. Okay, so now let's go down a little further here, and you need to change a word for me, please. To find out what type of solutions you will have, you look at the discriminant. And again, the discriminant is b squared minus 4ac. The discriminant is the part of the quadratic formula that is located under, so it does not include the square root sign. Underneath the square root sign, it does not include the square root sign. It's represented by b squared minus 4ac only. Okay, so what I did is I took the two questions that we just did, and just to show you how the discriminant works. So here I'm just going to quickly pull this down because we already did the same exact question up above. But when we do the b squared minus 4ac, we're going to end up with 40. Well, 40, if we come back to our chart here, 40 is greater than 0. So that means we're going to have two distinct, so they're going to be different, real solutions. Now if we go back up to, and when we say real, that means we don't have an I in the solution. When we go up to our answer, we have 4 plus 2 times the square root of 10 over 4 and 4 minus 2 times the square root of 10 over 4. So there are our two solutions. The second one I did was the second problem that we did at the beginning. And just to show you that if you'd worked the whole problem out, then you can tell that we correctly identified the discriminant and interpreted it. Okay, so here we have our a, b, and c, and we're substituting those values into b squared minus 4ac, and we end up with a negative 95. Okay, if we go back up to our table here, we see that if the discriminant is less than 0, which means that it's negative, then we're going to have two complex numbers, two distinct non-real complex solutions, which makes sense because if you think about it, this is underneath the square root sign. So let's go back up to the actual problem that came from. When you have a negative number underneath the square root sign, when you simplify it, you're going to have an I because you have to take out that square root of -1. So that makes sense. If the number b squared minus 4ac, which is the value that's underneath the square root sign, is negative, you're going to have two complex solutions. The last example wasn't up above, but we just want to talk about why it would be 0. If, just scribble this off, we have two equal signs there. I want you to write that as an equation. So the first thing that we need to do is subtract 12 from both sides, and that's going to leave us with this equation. And then we're going to identify a, b, and c. So a is 1, b is -12, and c is 36. And if we quickly substitute those values in, this is b squared minus 4 times a times c. And when we simplify that, we're going to get 144 minus 144. Well, that equals 0. Now, if we go up to our table here, it says if we end up with 0, exactly 0, there's going to be only one solution. Now, I didn't give you a problem like that up above, so I want to show you. We'll work this one out all the way, and you'll see that we're going to have one real solution. So finishing this problem up, if we put that, we already figured out b squared minus 4ac, so we're just going to substitute that in there, and then we have the negative b, so it would be positive 12, plus or minus the square root of 144 over 2. Well, 144 is a perfect square, so that's going to give us 12. And I just changed that to a 0 because that's the discriminant. I had 144 under there. I'm not sure why. I must have just seen that. So change, if you wrote down 144, change that to a 0. Okay, so what happens, this becomes 12, and we have the square root of 0 is just 0. So what we have is we have 12 plus the square root of 0, or 12 plus 0 over 2, which is 6, and we have 12 minus 0 over 2, which is 6. So we have one distinct, which means they're not different. And when we have, this says when we have 0 as b squared minus 4ac, we're going to only have one, let me move that down a little bit, we're going to have one distinct real solution. So this is actually a double root, but there's one distinct solution. All right, there's an application problem on the back that we're just going to go over in class. So I'm going to have you do the two you try it questions at the bottom, and then we'll talk about the application question in class.